Yeah, we are doing exercise 2.2 now. Students, I have left few questions in between which you can try easily, and those questions are very similar to the question which we have done already. Now see question number 1. Prove sine inverse x equal to sine inverse 3x minus 4x cube. Here we know that we just have to observe 3x minus 4x cube. This is a formula of sine 3a, a kind of formula. Sine 3a equal to 3 sine a minus 4 sine cube a. Now we can say sine a as x. This implies that a equal to sine inverse x. So 3a, if I shift this sign other side, then 3a will be sine inverse 3 sine a minus 4 sine cube a. Now I can say a as sine inverse x and sine a as x. So I'll be getting sine inverse 3x minus 4x cube, which I need to prove. Now in the second one, we have to prove that tan inverse 2 upon 11 plus tan inverse 7 upon 24 is equals to tan inverse 1 by 2. We know the formula tan inverse x plus tan inverse y is equals to tan inverse x plus y upon 1 minus xy. Now applying this formula, we can write tan inverse 2 upon 11 plus 7 upon 24 upon 1 minus 2 upon 11 multiply 7 upon 24. In place of x and y, I have just written 2 upon 11 and 7 upon 24 respectively. If I'll take LCM, I'll be getting 48 and 77, and in denominator 11 into 24. Same here, 11 into 24, 264 minus 7, 2 7s are 14. 11 into 24 again LCM, so I cut that part. If I add it, 48 plus 77, 125. If I add 264 minus 14, I'll be getting 250. So after substituting that, after reducing it, I'll be getting 1 by 2. So hence proved. This was to prove. Now we are discussing very important concept. In order to simplify the following substitutions, some substitutions are very important. This expression a square plus x square, if we substitute x by a tan theta, we can solve it easily. Similarly, a square minus x square, x equal to a sine theta. X square minus a square, we can substitute x by a sec theta, and root a minus x upon a plus x, we can substitute x by a cos 2 theta. Similarly, a square plus x square upon a square minus x square, we can substitute this x square by a square cos 2 theta. If you remember this, this kind of substitutions can be very helpful during solving questions. Now we are applying this kind of substitution in question number 5 NCERT. Write tan inverse root 1 plus x square minus 1 upon x. X is not equals to 0 in the simplest form. So what we have to do, let x is tan theta, and in that case tan inverse root 1 plus tan square theta minus 1 upon tan theta. 1 plus tan square theta, we know it is tan sec square theta. After taking root of this, we'll be getting sec theta minus 1 upon tan theta. Now just take LCM. Sec theta we know 1 upon cos theta, and tan theta is sine upon cos. If we take LCM, we'll be getting 1 minus cos theta upon sine theta. Now by using half angle formula, we can say 1 minus cos theta as 2 sine square theta by 2, and sine theta we can say 2 sine theta by 2 cos theta by 2. We can reduce it, then we'll be getting tan inverse sine theta by 2 upon cos theta by 2 equal to tan theta by 2. This tan inverse will be cancelled, then we'll be getting 1 upon 2 theta only. Theta is from here we can say theta is tan inverse x. So 1 upon 2 tan inverse x. This is the answer. Now see the next question 7. Simplify tan inverse root 1 minus cos x upon 1 plus cos x. We can say cos x as, we have the direct formula for this, we have studied this in class 11th. 1 minus cos x is equals to 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. If we replace this formula here, we'll be getting 2 sin square x by 2 upon 2 cos square x by 2. Just reduce it, we'll be getting 10 x by 2. 10 inverse 10 cancelled with each other, then x by 2 will be the simplified form. This is very important question. Question number 10. We have to simplify tan inverse 3a square x minus x cube upon a cube minus 3ax square. Now we will divide the denominator and numerator by a cube. Tan inverse 3x by a will be getting minus x upon a whole cube 1 minus 3x square upon a square. Why we are dividing it by a cube? The reason lies behind the formula. Tan 3 theta is equals to 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Now we can say x upon a as tan theta. We replace the value 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Now this whole you can write by the formula tan 3 theta. This tan inverse 10 will be cancelled out, then 3 theta will be 3 theta equal to 3 tan inverse x by a, as we have already assumed tan theta as x by a. Now let's try question number 13. Find the value of tan 1 by 2 sine inverse 2x upon 1 plus x square plus cos inverse 1 minus y square upon 1 plus y square. We have got this question twice or 3 times in the board examination, so this is important one. Now we know the formula, we have already studied during when we were studying properties. Sine inverse 2x upon 1 plus x square equal to 2 tan inverse x, and cos inverse 1 minus y square upon 1 plus y square equal to 2 tan inverse y. Now we can directly use this formula in the question. We'll be getting tan 1 by 2 2 tan inverse x plus 2 tan inverse y. Just take LCM, just take 2 common, we'll be getting tan inverse x plus tan inverse y only. So tan inverse x plus tan inverse y, we know the formula tan inverse x plus y upon 1 minus xy. Now tan is already there and we have tan inverse, so it will be cancelled out. We'll be having only x plus y upon 1 minus xy. Now question number 14. If sine inverse 1 by 5 plus cos inverse x equals to 1, then find the value of x. We have to find the value of x. Sine inverse 1 by 5 plus cos inverse x equals to 1. We'll replace this sine other side, it will be sine inverse 1, and sine inverse 1 is pi by 2. If we replace, if we transfer sine inverse 1 by 5 other side, it will be pi by 2 minus sine inverse 1 by 5, and we know the formula, very important formula, sine inverse x plus cos inverse pi by plus sine inverse x plus cos inverse x equals to pi by 2. By using this formula we can say pi by 2 minus sine inverse 1 by 5 is equals to cos inverse 1 by 5. If I'll cut cos inverse both sides, I'll be getting x as 1 by 5. This is the answer. Now see question number 15. In question number 15 we have to find the value of x again. And what is given to us? If tan inverse x minus 1 upon x minus 2 plus tan inverse x plus 1 upon x plus 4 x plus 2 is equals to pi by 4, find the value of this x. So we'll use tan inverse x plus tan inverse y formula in this side. First of all, tan inverse x plus tan inverse y. So by the formula we can write tan inverse x minus 1 upon x minus 2 plus x plus 1 upon x plus 2 upon 1 minus x minus 1 upon x minus 2 x plus 1 upon x plus 2 and is equals to pi by 4. Just take LCM x minus 1 into x plus 2 and x plus 1 upon into x minus 2, cross, and just multiply this way. It will be a plus b, a minus b. A square means x square minus 4, 2 square is 4, minus x square minus 1. So tan inverse, this tan inverse will already here, and pi by 4 is already here, means these positions, their position have not been changed. Just you have to simplify the bracket. We'll be getting x square plus x minus 2 after solving this, and you will be getting x square minus x minus 2 by after solving this. So here you will be getting 2x square minus 4 upon minus 3, 2x square minus 4 upon minus 3 is equals to pi by 4. And then this tan inverse I'll shift other side. I'll be getting 10 pi by 4, and 10 pi by 4 is 1. We know the formula. And then minus 4 will be other side, will be getting 1. Minus 3 plus 4 is 1. Then just divided by 2, so x square is 1 by 2, so x is plus minus 1 by root 2. So this is the final answer. Now question number 16, find the value of sine inverse sine 2 pi by 3. Sine inverse sine 2 pi by 3. We know that we can write sine this 2 pi by 3 as pi minus pi by 3, and we know that sine pi minus theta is sine theta. So in class 11th we have studied this formula. Now we are applying this here. Sine inverse sine pi minus pi by 3, and sine pi minus pi by 3 is sine pi by 3. Then sine inverse sine cancelled, we can say it is equals to pi by 3, because this is lying in the interval minus pi by 2 to pi by 2. Basically we have to try in such a way that whatever answer is coming this at this point, at this place, it should lie between minus pi by 2 to pi by 2. Now students, rest all the questions are for you. You will try by yourself in this exercise. If you find problem in any of the question, you can write in the comment section, and please share this video so that other students can get help. Thank you.